Hello everybody. Here we're going to do some examples of geometric probability. As you can see from these 6 exercises, we're to find the probability that a point chosen at random lies in the shaded region, round to the nearest hundredths if necessary. For the very first one, we have a 9 by 10 grid giving us 90 small squares. And if we counted every one of these, it comes up to 48. So then we have 48 out of 90 squares shaded. As a decimal, 48 divided by 90, 0.53. You can think of that 0.53 as 53%. So there's a 53% chance of choosing a random shaded square as opposed to an unshaded square. Number 2, we have a 10 by 10 grid. It comes out to 100. And if we count the shaded squares, there are 30 of them. And so that gives us 0.30. Okay, for number 3, we have a square. First of all, we're going to get the total area of the square, 12 by 12, that's 144. We're going to subtract away the circle. Now the circle has a radius of 6, so that means the area would be 6 squared times pi, which is 36 pi. If we do that in the calculator, it comes out to 30.90. 30.90 square units is the shaded region. We need to write that as a ratio over 144. So we have 30.90 divided by 144 comes out to 0.21. So once again, 21% chance of choosing a point somewhere in the shaded region. For number 4, first need to find the overall area of the square, 24 by 24, which is 576. We need to subtract away 4 circles. Now each circle we need to figure out the radius. Well, all the way across 2 diameters is 24. That means 1 diameter is 12. 1 radius is 6. So there's our radius, 6 squared times pi. If we take 576 minus 4 times pi 6 squared, we get 123.61. Then we need to write that as a ratio over 576. And in the calculator, it'll yield 0.21. So again, a 21% chance of choosing a point in the shaded region. Now for number 5, we have a rectangle, and this is a 16 by 12 rectangle, and that comes out to 192. And we need to figure out the area of the shaded region. Well, we can see that this is a rhombus. We can prove that through Pythagorean triples. We've got 4 right triangles in the corners. Each of the hypotenuses are 10. So we know everything's congruent. Each side is congruent. What we have is a rhombus. And we can take the diagonals of the rhombus, multiply them together, and multiply them by 1/2. That'll get us the area of this rhombus, 1/2 times 16 times 12, just the area of the rhombus. And all this in the calculator, it's exactly half, 0.50 of the total area. 50% chance of landing somewhere in the shaded region. Finally, for number 6, when we have a big circle, and then we have a shaded circle on the inside with another white unshaded area inside. We first need to find the whole circle. And if we add up all these segments, it adds up to 6. The radius of the largest circle is 6. 6 squared is 36. So the total circle that we're after is out of 36 pi square units. The shaded region, think of it as this circle here that goes from here out to 3. From this region is 3. 2 plus 3 gives us 5. That is 5 squared times pi. But we're going to subtract away the circle here in the middle, and that has a radius of 2. 2 squared times pi. And so there's our ratio. The top represents the shaded region, the bottom represents the entire region of the circle, and in the calculator, putting it all together, comes out to 0.58. So there's a 58% chance of choosing a point in here that is shaded.